So I'm the founder of, and ex-CTO of Backsense, a company that we're doing mobile analytics, quality metrics, error reporting, a lot of interesting stuff. You'll see in the later slides. And I've been programming Erlang since 2008, something like that. So this is actually my third, fourth biggest big-scale project. So this is the Backsense team with everybody's wearing glasses but me because I'm the founder and everybody wants to see me. No, I'm kidding. We were, most of the team, 11 engineers, were in Greece. We were traveling around the world. I'm Greek, as you can find out from the accent. So we had offices. We were a very small startup, only got $100,000 as seed funding, which is nothing if you see what other companies in the Silicon Valley managed to raise. So we had offices in San Francisco, Europe, and also Japan. We managed to become the second biggest player in the mobile, meaning that it's Google, us, and then it's chaos, just with $100,000. That's mostly due to Erlang, as you will see, and I'm not kidding. So, a little stuff about what Backsense is. The second biggest SDK in the world after Google, meaning that if you have a smartphone, Android, iOS, Windows Phone, probably you already have Backsense installed. That means that when an application goes wild and starts crashing, we are there, we're collecting the data, we're notifying the developers what went wrong, and we're pushing new versions to your device. We're analyzing data in real time for more than 500 million devices, using only 19 servers on Azure. If you can do the math, competitors are doing something similar, not in real time, using around 2,000 servers. Not using Erlang, using Java, but yeah, too bad. So we have a custom big data database built on Erlang C using a LISP layer, yeah, and 11 engineers. And Backsense was a cash positive, of course, because we didn't have 5 million in the bank. We had to become a cash positive company. So after probably, Backsense was a 2 years old startup. After a while, we got acquired by Splunk, which is a big data company doing operation intelligence, gathering logs from hundreds of devices and analyze them in real time. They didn't have Erlang, but they thought that it's very interesting that a small startup having that huge technology could help them enter the mobile space. So, while we're starting, while we're in the due diligence process, which is the process when someone wants to acquire your company, we went all through the financial, what happens with visas, what technology you have, what are you using. And at some point we said, yeah, we have a custom database built on Erlang. Oh yeah, we've heard Erlang before, yeah, it's a cool, we're thinking about also using it. But what's so special about Erlang? Why you're not using Hadoop? So we have, me personally, I don't really like Hadoop. I don't know, maybe it's because Java, or maybe because Hadoop was never meant to do real-time, soft real-time analysis. So I really hate it with passion. So we told them, of course, we're not using Hadoop to do real-time analysis or analysis at all, because if we were using Hadoop, we would need 1,000 servers to run MapReduce, and it would be possible to do real-time. So we have built a custom database called LDB, which is an in-memory database, actually can store, of course, on the hard drive, doing a lot of correlations as processing in real time. We'll see in a little bit more details, built on Erlang and C. LDB Facts. So we're a complex event processing in memory, meaning that we can handle a huge stream of data coming from 500 million devices around the Earth, analyze them in real time. It's super easy, just one Erlang package, as you install it, bam, you are already running. No tables, no row, no column logs, everything runs asynchronously. C definitely runs circles around Java. It's extremely fast and predictable because we have no garbage collector. And we have a system that allows us to lazy loading of files. This is this is one of the things that we told them during the due diligence. So we're describing that this database is awesome, it's the next big thing, it's perfect, it's on Erlang rocks. And they looked at the last line and said, let it crash. come on, we are building enterprise software. What do you mean, let it crash? Seriously? So they told us, how can you build a database that you can let it crash? Doesn't make any sense. We build software that should never crash. So one of our architectural decisions from the beginning was, if we build a database in order to have 30,000 customers running on the cloud, accepting more than 500 million devices connections every single day, at some point definitely the database will crash. 100%. Maybe it's the server that will run out of memory allocation, something will go wrong, the server will crash more than one time. It doesn't matter whether you build the perfect system out there, accept it, you won't build it, but it will crash. So we designed the whole database around, yes, things will crash. So we said, okay, not only we're going to let the database crash, but we can squeeze more free customers to a single node. When, let's say that a single node can handle 5,000 free customers. We can squeeze 10,000 unique customers, 10,000 free customers, and because not every free customer goes and logs into the service every day, and when the limit will be hit, doesn't matter, the system will crash and will start extremely fast. Because we can load all our customer base in less than a second, extremely fast. We're doing lazy loading of files. All the other databases, of course, we tried Redis, we tried Mongo, and you'll see in a while why we didn't choose them, had exactly this problem. It was very difficult to do asynchronous stuff. With Erlang, it was trivial. Actually, we were doing a lot of prototyping, meaning that we wrote something in Erlang, and after a couple of weeks we said, yeah, I don't think that works, we should do it asynchronously. And in 5 minutes, we just put an A in front of sync, and we could test this out. Also, it was trivial, I mean, really trivial, to re-architecture everything. The code base, the prototype that we originally have, was using Nisia. So we wrote the first prototype in about a week, where in C and in other languages, the first week we were just trying to set up the environment. So, let me tell you a little bit about Nisia and why we have a custom database and we're not using Nisia. Nisia, and I want this to be recorded there, is fucking awesome. So, we were writing a C layer, we have written a small C library, just a hash table, where we're adding stuff, you know, add this key, increase a counter, and I was stress testing it, putting, I don't know, something like 2,000 keys per second, increasing it, and I said, let's see if how slow is Nisia compared to my C code. Nisia was faster than my C code. My C code was something like, I don't know, 500 lines of code with using Murmur 3 for, I think Murmur 2, Murmur 3 wasn't out there yet, Murmur 2 for the hashing function, and Nisia was kicking my ass. And I was, seriously, generic database is faster than my custom code that actually does one assembly line of code, assembly line instruction to an increase. How this could be fast? Of course, this wasn't distributed. It was one node, probably it was directly hitting the ETS, never writing to the hard drive. But again, this is amazing. So the only reason that we didn't use Nisia is the 2 GB, 4 GB limit and storing to the hard drive. So we said that we're going to build a system where we accept thousands of connections. We're going to have an Erlang receiver in Cowboy. We're going to write a small Erlang router, all this in the same package. And we're going to start a C layer using a LinkedIn driver to communicate between the Erlang part and the C part. And we're going to store everything in the C memory space. We did that because we actually have a LISP called LQL, we're going to see in a while, where you can run queries, actual queries on your data. Why we did that? Why we use C? Because Erlang is extremely fast and easy, of course, to handle thousands of connections per second. But we wanted a language that was easier to write, meaning, not for us, but for other developers. So we said we're going to have something in Lisp. It definitely needs to be on the same memory space, thus the LinkedIn driver, and we can run whole calculations in real time on every single request. That means we're not just increasing counters. We could tell you that on every single request that comes, we could tell you that this user hasn't been to the website for the last 3 months, he was using this app version, he had a crash, all this on every single request, meaning that we are doing a huge correlation, a huge calculation, something like 10,000 times per second. C is extremely fast on that, and Erlang is extremely sufficient in communicating with the C layer. Sometimes we kill the scheduler, but I'll tell you about this in a while. Now, we also wrote a replicator, meaning that a replication engine that if the database goes down and we lost the node, we need to have other nodes standing by. So I remember I wrote the replication engine in Erlang in around 3 days while I was on vacation. Wait, it wasn't a full replication engine like Hadoop with zookeepers and stuff like that. It was a very simple a module that was doing RPCs, was sending heartbeats to all the other nodes, and I didn't build it that fast because I'm a fast engineer, I'm a smart engineer or something like that. It was because Erlang had already everything in place. I could just do an RPC call, yeah, this node is down, elect a new node and automatically start retrieving data and electing this node as a master. Seriously, it's maybe 200 lines of code of Erlang, something like that. And I think I've open sourced that because when we started building the replicator, everyone said to me, you're going to build a replication engine? And I told them, guys, it's not an engine. It's just a couple of lines of codes of Erlang trying not to mess things with the file system or do the elections the wrong way. So the only thing that I don't like Erlang is that when you're doing stuff that other languages for other languages seems like a huge burden, for Erlang it seems so easy. So you cannot say that, yeah, I spent 2 weeks building that. You said, I've built a couple of days. So everybody says, okay, it's a couple of days. How good could it be? Guys, it could be really, really, really good. So this is an example of our LQL, of our custom LISP database. And I could point you to high scalability articles and not of articles or article books that we've released this query language. So what we do here is we return a JSON format having 7 values as a time series 7 days ago of counting how many unique users. So with this line of code, we can return you a JSON of how many unique users you have for each day. The JSON is automatically created and stuff like that. Why we choose Erlang? So at first I tried Java. I'm a very, very, very bad Java developer, which I think it's not because Java is bad, because I can't spend a lot of time. Actually, I'm a lazy developer. Yeah, I admit it. I cannot spend lots of time writing code and then say, oh, I made a mistake. I need to change all my interfaces and stuff like that. I'm lazy. I cannot do that. I have more important things. I'm not having fun. So Erlang, we just installed Cowboy, and we had a web server that could scale fast, and most importantly, I could understand its code. That's very important. Now, sending and receiving messages between nodes, it's so easy that sometimes my personal opinion, we are overcomplicate things because we say, okay, let's start a node there and we'll send a message, another node there, because no other language can do it. So we'll say, okay, let's overdo it because it's that easy. So it takes a little bit of time saying that, okay, I'm not going to over-engineer this. It works as it is. There's no need to spawn a new process on every single request, for example. Been there, done that. Yeah, building a replication engine was extremely easy. You can imagine. I think also Joe Armstrong had a blog post about how to copy files between different Erlang nodes. And what was doing was he had a node there, and was doing an RPC file system call from one node to the other. And everything copied over the files, over the network, just like that. File copy, you get the data, you write them on the other side. Just like that. 2 lines of code. Mnesia is awesome if you want to share files across all your architecture. You can imagine how awesome it is that the system, I won't say 99.9999% reliable, I would say 100% reliable because we never had a failure due to Mnesia. Now, I think you could definitely, someone could misconfigure Mnesia in order to drive it to the ground, but in general, if you use it just to share files, configurations among your architecture, it will work and it will scale. LinkedIn drivers. So the big question was, why don't build everything in Erlang? If we built everything in Erlang, we wouldn't have the C processing that fast, all our data. We couldn't use custom structures or store to the hard drive. We're doing all the storage in the hard drive. We're not letting Mnesia do it due to the 4 GB limit. So we decided to go definitely for a C node. So at first we said, okay, why not build a C node instead of a LinkedIn driver and have the Erlang communicate like it's a true Erlang node? The problem there is that we wanted the C codes to be part of Erlang because we wanted everything to run in the same memory space. Meaning that, imagine that you have the Erlang cowboy part and you have a request, a binary request. Now, this binary blob, let's say, this binary data is in some address in memory. The LinkedIn driver could have access to that exact memory. It could handle it, it could do whatever you like. If you send it to another node, you need to do serialization, deserialization, opening sockets, and send it to the other side. So having the Erlang collecting data, putting in memory, and having a C layer aggregating and doing all this stuff right there, the same memory space, made the whole system extremely fast, and you'll see in a while that sometimes this backfires. Also Erlang is trivial to connect to remote nodes, meaning that at some point we wanted to investigate what was going wrong, why the mailboxes were getting fuller and fuller, so you could just remote connect to the Erlang part and figure out at least what's going on. And most important, all this was in one language. So when I started building this in Erlang, everybody told me, why build a database? Use a Java database. Why build? Why do you need a server? Tomcat, Jetty, Netty. There are so many. Yeah, there are so many different packages. So I have to maintain the different release, new release, compatibilities, and try to package all this stuff in one package, which doesn't work all the time. What I really want to do is have one Erlang package, do a make, have everything deployed, and done. So Erlang it's best for that. It has a database. Installing Cowboy is trivial, and making it using a rebar, making it a package is super easy. So yeah. Why C? 19 Azure machines, which are pretty crappy, handling more than 30,000 live customers. This is huge if you consider that how difficult to have 30,000 customers, meaning that 500,000 million devices sending data and handling all the traffic, doing calculations in real time, complex calculations, just using 19 machines. If we were using Hadoop or some other technology, sorry for hitting all the time Hadoop, yeah, you would need one machine, probably two for Zookeeper, a couple of machines to do the map, and the rest probably do the reduce if you manage to set it up. So we're doing a lot of correlation and processing in real time using the C layer, real time. Nothing actually locks the database, meaning that the database could read data from the file, could write data from the file, while someone is writing, increasing a new indexer or a new counter or adding something. There's no locking involved. Everything runs asynchronously and lock-free and very predictable, at least the C layer, because we have no garbage collector. Sorry. Why Lisp? So I'm a huge fan of Lisp, and I really wanted to have Lisp inside Erlang. I know the LFE project, but we wanted something that would be extremely fast in the same memory space and be able, actually wanted to write a Lisp interpreter. So yeah, I said, it's my company, I'm going to do whatever I want. So this proved very well because we're able to write small DSLs on top of this language. And at some point, the abstractions we had so many abstractions that I was saying, okay, can we write an SQL, just SQL our data? The abstraction layer was so far that it was awesome. And the most important thing is that everybody could have its own standard library, so you could say instead of increase counter, you could overwrap it and said something like new customer or new hit, new button clicked. Trivial, very easy, and yeah, no, I really love the abstractions that Lisp can offer. Yeah, writing a parser, lexer, and interpreter in Lisp. Seriously, it's today's work. Again, I'm not very smart, not smart at all, but it's extremely easy because I could point you to blogs where people have written the Lisp interpreter in something 30 lines of code. Extremely easy, not efficient, but okay, we have Erlang, we have C, we don't want to go any more faster, it works. We could write SQL DSS, expressive power, blah, 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 blah. Data transformations, and because Lisp is so awesome, it's trivial to do data transformations, and data transformations is everything when you want to do big data analysis. So for a long time, even I think from the beginning, we were thinking about releasing LDB as open source. We had a lot of people asking it, and we really wanted feedback from the Erlang community. But for a long time, we were thinking whether we should remove the C layer or keep it. The C layer has all these advantages, the Lisp awesome part, extremely fast, you could use you could use statistical libraries, a lot of data structures, but having everything in a single language, Erlang, I don't know, feels a little bit better. So the LDB3, which is currently under development and we're thinking where it's going to go, is probably Erlang all the way. It's going to have Erlang everywhere. In order to keep the scheduler happy, because the scheduler is not happy when you're calling LinkedIn drivers that take more than 1 second to respond. Much faster development. And one thing, even though I think I have a slide afterwards, about LinkedIn drivers is that LinkedIn drivers, guys, are awesome. Extremely fast if you're going to do something very, very small. Everything is great, same memory space, blah, 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 blah. The thing is that if something goes wrong to your C LinkedIn driver, the whole Erlang node goes down. No supervisors, nothing at all, because you are in the same memory space like the virtual machine beam, everything goes down. Which sometimes you say, it's in the game, but you're losing a huge feature of Erlang, the auto-healing mechanisms. So I'm not pretty happy when a machine goes down and I'm, okay, goddamn you pointer. Yeah, so, yeah. And of course, this actually, the much faster line came as a surprise as we ran some tests a couple of days ago, is that if you try to do everything the Erlang way, on some specific cases, it's faster than the C way. Meaning that we saw running performance tests that we spend a lot of CPU time doing, the operating system doing locking and unlocking between processes. And that's 100% due to the C layer. So we said, okay, let's remove the C layer, not run calculations there, and just let's run simpler calculations, not writing a DSL yet, in the Erlang part. And oh my God. Even if you were just copying again data structure and stuff like that, it was, I don't know, Nick, do you remember how many times it was faster? Yeah, we had the graph, it was much faster because there was no locking and unlocking going on in the CPU bus. So that's one of the reasons we said that, yeah, maybe Erlang, yeah, why not? We have all these guys here in the room committing and helping us out. So, why we should remove the C layer? I've been pitching you all the time how awesome C LinkedIn drivers are and why you should always use a C LinkedIn driver if you want to do something that requires heavy processing power. So why? So, LinkedIn drivers. If you crash the C layer, as I told you before, it's going to crash the VM. I had the discussion, I think a couple of weeks ago, with some crazy hacker that was trying to trap the signal error and notify the Beam VM, bring the supervisor, because this doesn't work. I'm pretty sure that with the new R17 version, some stuff like this will change, so you'll have to maintain your code between different versions. That doesn't work. And if you start adding code to your C layer in order not to crash it, then you're not using Erlang. You should let it crash, the supervisor will restart it, everything will be better, and you shouldn't try to figure out what went wrong. So scheduler is not very happy when we're executing stuff that takes more than 1 millisecond up to a second. Meaning that the scheduler knows that I have Erlang threads that I assign them this process for this time and blah blah blah. When a LinkedIn driver comes in, the scheduler doesn't run exactly the same. So you might see a lot of stuff like that, and yeah, it's not very good. So it's very difficult to scale horizontally, very, very difficult, because the whole idea is that you want everything in the same memory space. If you want to scale horizontally, there's no point to keep it in the same memory space. So why use the LinkedIn driver? You could just harvest the Erlang's power and scale horizontally. Now, on the first implementation, I was getting the data coming from the cowboy. I was deserializing it. I was serializing it as a C in order for the LinkedIn driver to understand what's going on, doing the process, and I was deserializing and I was serializing again back to the Erlang layer. If you're not careful, meaning that if you just throw a huge JSON or worse XML data coming in serialization, you're going to kill the performance. LinkedIn drivers are fast when you're not doing a lot of serialization, deserialization all the time. So if you want to optimize something, this is the place to optimize. This makes a huge difference between sending data back and forth and between different nodes. And of course, if you're using LinkedIn drivers, you need to test 3 times. Every time you write something, you need to test it 3 times, because I can tell you from the experience of having 30,000 customers cursing and calling me at my mobile phone, is that when you said, it's done, I can release it, it won't be done. The moment it goes up, something will go wrong on the C layer, malloc, free, a pointer shouldn't point in another direction, it will go down. That's the first time. The second time we will say, okay, it's fixed, it will go down, and the third time you'll say, what everybody's, stand behind you, come on man, you need to fix it, probably it will work. So even if it was having a LinkedIn driver and a C layer, it was very, very good. I hated the times when I couldn't figure out why the Beam VM is crashing. And I knew deep in my heart that probably the Erlang guys didn't do a mistake, and it might be my code. So yeah. Now, what's good with the LinkedIn drivers? If you make it work, it's blazing fast. Imagine that you have, I don't know, tons of data in memory, and you could have the C layer running extremely fast, doing calculations, writing to file system, reading from file system, extremely fast, if it works. You could use a lot of C libraries and special data structures. It was very easy for us to write a HLL counter, the high probabilistic counters, in C. Very difficult to write it in the Erlang part, mostly because the R16B I think we're using, doesn't have a hash table. So whenever we want to use a hash table, we needed to create a new instance, so it was difficult to write, difficult to maintain, didn't feel natural. So the advantage you have with the LinkedIn driver, the C driver, is that nothing is immutable. You could screw all your data, you could erase data, move the pointer around, because data it's a playground until you crash something. And legacy code, meaning that, hey, I've written a C library in 1980. Yeah, it was pretty fast writing files to the hard drive or reading files. I wish I could use it. Yep, it will work and you will be very, very happy. Now, as I said, a lot of people told us about what happens with LDB now that Backsense has been acquired, if we're going to open source some parts of it. There is a possibility that we're going to open source some parts of it, probably the older version using the C layer part. But what I really want to do is release the old version, see my crappy C code and my LinkedIn drivers, curse me on Twitter saying, hey man, you shouldn't use malloc, but you should use a pmalloc because it does blah blah blah. Yeah, I've heard this so many times. But I think it's a masterpiece when it comes to LinkedIn drivers. Not from the code, not because of the code, because of the comments. Damn you LinkedIn drivers, I won't do this again, and stuff like that. So probably it's a teaching experience. Somebody that reads the code, and especially the commits, it's a lightning experience. Now, the new version, the LDB 3 version, we're thinking about starting a community version, meaning, okay guys, let's talk all together, let's build everything in Erlang, because as I see it, there's not a stream database right now. Meaning, has anybody here heard about Storm? So, Storm is a stream processor, not a database, stream processor built on Java. The thing is that, has anyone here managed to install Storm? Okay, so everybody heard it, nobody managed to install it. The thing is that this thing has so many components. Okay, you can do everything. Seriously, you could put anything you want in the Storm package, but you can't install it. You try to have one installation there, doesn't work. You need also that older version. You do that. There's documentation 3 years ago. You could do it. Doesn't work. And so it has a lot of moving parts because Java doesn't have a database built in. That's you could use and stuff like that. And what's most important is it's just a stream processor. LDB is a stream database, meaning that the database part and the processing part is done in the same place. So because everything is the same memory space, it's extremely fast. And sometimes that works that works very, very well, and you don't need everything to be horizontal scale and web scale as MongoDB says. You could just have one instance with lots of memory, and let's admit it, not all startups are like Google. Probably it will work for 99.9% of all the startups. So I was searching for other databases that are doing it right now. Just an instance, a small instance where I could start it and I could feed data, run some queries, not especially, not LISP, it could be Erlang or Elixir, I don't know, and have my data processed and output, maybe not 10,000 requests per second, but it could be 100 requests per second like most of our needs, and there wasn't a single one. I saw that there were some people trying to do it in C, good luck, and they taught everything written in C, and there were some people trying to do it in Java, but again, if you want to install, you should have a package manager, but you need to build the package manager, so yeah. So I think there is a huge possibility there, and I would be very happy when this talk, when I finish this talk, if we could talk about if you guys want to really help us out with building a community version. So if you want to ask me everything, this is my Twitter handle at Jon Romero. Thank you guys for listening. If you have any questions, now is the right time. Yep, done.
Oh, you got time. If there's any questions, please ask.
I know that you guys have many questions. Don't be afraid. I will choose randomly. Okay.
I'm curious, how are you storing the data?
So,
what's the format when you get down to the C layer and store it on disk?
So, most of the data are stored in different hash tables. So we are serializing the hash tables to a format called LIF. Now, from LQL, from the LQL files. Now, LIF comes from an old file format called RIF, R-I-F-F. So it's a very flat file that we just take it and store it to the hard drive. Now, imagine that if someone sends you 50 gigabytes of data, right? The LIF file could be 2 kilobytes. Why? Because we're only keeping the aggregated data. Because we're a processor, when you send us 50 gigabytes of data and you ask LDB how many unique users you have or how many sessions this user made, these are just counters, just simple integers. So for huge customers, like customers that have more than 5 million unique users per day, the data file is usually around 1 megabyte, something like that. So it's very efficient storing only the aggregated data. Of course, using disk log, another awesome component, disk log, we're also, again, built in Erlang. We're storing the raw files, the raw data in the hard drive, in case something goes wrong and we need to replay the data. Just a note on disk log, the best and the fastest system in order to send data from a node to the hard drive. Scales horizontally, could run distributedly, extremely fast, again, built in inside Erlang. Yep. Yep.
What's the L in LDB stand for?
The L. So, that's a great question. So the L comes from the word lithy, meaning L-E-T-H-E, if you guys want to Google it. Lethe. So lithy, or as most US people call it, lethe, used to be a river in ancient Greece when someone died, was going down there and was drinking from that river to forget. So because it's a memory database, we thought it was fun that it was a database that forgets. So yeah, that's yeah. And because people couldn't pronounce it, actually, if you Google Lethe Baxens, something like that, you'll see the first logos, instead of saying LDB, we're saying Lithy LDB. But while I was in the US, everybody said, so tell me about Lethe. And I couldn't study it. I was, okay, LDB. Yeah?
What would have been the impact from the beginning had you used Erlang all the way through? Do you have a sense as to the number of machines you needed and the performance degradation?
With the knowledge I have now, and I know what went wrong, I think that probably our main bottleneck, we're using 19 servers and we're working to optimize it to use even less servers, is memory. Because everything is stored in memory, we need to do aggregations, that's our main bottleneck. So if we're using Erlang, we will go much faster, the whole system will run much faster, but I don't think we will use less servers because again the data will need to be again in memory. But what we could do, we would be able to squeeze more customers to a single machine or run more complex scripts. So I think that we might be able to squeeze, instead of using 19 or 20 machines, do something like 15 machines, something like that. But the huge advantage is that a node wouldn't go down without us knowing why this node died. We have the Erlang VM auto starting it, we have all the logging in place. With the C layer, sometimes the system crashes and you get a beam export, something went wrong and we don't know what happens. We need to bring up the assembler and start to figure out what's going on, and yeah, we never do that.
So are you saying that it might have been a better decision to go with full Erlang all the way from the beginning?
I think that actually I will be able to answer this better in a couple of months while we're building the next iteration. At some point, every developer hates the first version of its product. So whenever I write my first version, after a couple of weeks I say, I don't like it, I should delete it and start from scratch. This happens with every single project we have. I think that's what's happening with LDB. We have a system that works very well, but we say, yeah, okay, but C layer, I don't know, I pretty much hate C when you can have Erlang do everything, so let's try Erlang. I think that it might work fantastically, but it might not work because we'll have all the issues with storing data. Because Erlang is so easy to do everything asynchronously and start different modules, I think it's very easy to over-engineer stuff. For the C layer, we couldn't over-engineer it because we knew that the more code we write, the more bugs we're going to introduce. So yeah, I'm going to answer you in a couple of months how this turns out.
What kind of luck have you had finding statistical libraries in Erlang to replace the C libraries you'd like to?
Yeah, that's a big question. So, yeah. In my spare time, I'm trying to write a system that it's like R, the programming language, that do some financial statistics and stuff like that. So I said, why is everybody using R? It's not fast, it's not scalable, blah, blah, and I wanted to write actually something in Erlang just to play around. So there are not that many. Actually, I couldn't find any financial libraries or statistics libraries or data structures in Erlang. There were some attempts, but slow, buggy, they don't work. And that's the only reason why I think we could just remove some libraries that we want, leave them in C, and communicate via beefs. But yeah, Erlang definitely needs a package that has like matplotlib that Python has or something like that. Yeah, like SkyPy, something like that. There's no statistical library in Erlang, so you need to run everything from scratch or use a C code.
What's one feature of the language or the environment that you felt
Okay, first it was that made every developer happy that we're building something very fast, and we weren't tied down to every decision that we made. Meaning that being able to say, okay, let's start a new node there, let's do everything that way. I know it's wrong, let's do it that way. And it was super easy to move between decisions. That was critical for us. So fast prototyping and deployment was super critical. Also REPL. The REPL that Erlang has, it's, oh my God, so sweet. You run something, you say, doesn't work, recompile the module, new version, it works, perfect, let's go to the next one. I think that, okay, the ability to communicate between nodes and stuff like that, okay, it's for granted. But I think the most important thing is that with Erlang, so an interesting story. Do we have time? A couple of minutes?
30 seconds.
Oh, okay, a very interesting story. I remember that I had written a program that was tried to read files from the hard drive, do some combination between the files, find the unique lines in Python, and after a while I thought, okay, I'll try it in Erlang. So the Erlang architecture was totally different from the Python architecture, and I could rewrite the Python part with the Erlang logic, where the Python code would seem like Erlang, like more functional. Like now, was performing better and was cleaner. So I don't know whether it was the functional aspect of Erlang or the aspect of Erlang that says everything should be in modules, you can communicate easily, but it definitely changes the way, shapes the way that that you think. So yeah.
Great, thank you.
Thanks, guys.